One of my other videos talks about finding the mean and the standard deviation for discrete random variables. This particular example is finding the mean and standard deviation and then using the mean and standard deviation for continuous random variables. So here's my example. A particular biathlon consists of a bike race and a long distance run. From years past, it is known that the mean time for the bike race is 33.6 minutes, with a standard deviation of 5.2 minutes, while the mean long distance run time is 45.8 minutes, with a standard deviation of 8.4 minutes. Each distribution of times have normal models. So I want to know, what is the probability that you run the entire biathlon in less than 70 minutes? I want to go ahead and highlight the most important information here. For the bike race, I know the mean is 33.6 minutes with a standard deviation of 5.2 minutes. And then for the long distance run, the mean time is 45.8 with a standard deviation of 8.4. When we're working with continuous random variables, or any random variables for that matter, and we are combining these two, we are actually adding them. So I'm taking the random variable for the bike race and I am adding it to the random variable information for the run. So I'll just call them B and R respectively. So to find the mean for the bike race plus the run, I just find the sum of their means. Okay, the mean of the sum is equal to the sum of the means. So in this case, it would be 33.6 plus 45.8, which gives us a mean time for the entire race of 79.4 minutes. Now for standard deviation, I cannot just add the two standard deviations together. I have to find the variance of each, then add them together, and then take the square root of that in order to find the standard deviation of the sum of these two random variables. So I'm going to take the square root of 5.2 squared, which is the variance for this standard deviation, plus 8.4 squared, which again is the variance for this standard deviation. And when I do the math here, I end up getting 9.9 for the standard deviation of the entire race. So now what I'm going to be doing to find the probability, since I'm using a normal model for a continuous random variable, what I'm going to do is use a normal model that has a mean of 79.4 minutes and a standard deviation of 9.9 minutes. This is the notation for a normal model. So down here, I've got my picture of a bell-shaped curve for my normal model. 79.4 is my mean, and I want to know, what is the probability that I run the biathlon in less than 70 minutes? So somewhere over here is the time of 70 minutes, and I want to figure out or find the area beneath that time of 70 minutes. So this purple area right here is the probability that I can run this biathlon in less than 70 minutes. Well, I have to use z-scores, and then I'm going to go ahead and use technology, my calculator, to find the area of this shaded region. I have to find the z-score for 70 minutes. Well, the formula for z-score is the observed value minus the mean of your distribution divided by the standard deviation. So in this case, it's 70 minus 79.4 divided by my standard deviation of 9.9. Just remember, there it is right up here at the top. The z-score for 70 minutes ends up being about negative 0.95. So at this point in time, I'm going to jump to my calculator, and I'm not going to show this on screen. I'm assuming if you've made it this far in a stats class, you know how to use the function normal CDF on your calculator. So my left-hand boundary and my right-hand boundaries are going to be negative 99 and negative 0.95. When I do the math here, I end up finding that the area of this shaded region is about 0.171, which is approximately 17.1%. So what is the probability that I run this entire biathlon in less than 70 minutes? Well, it's about 17.1%. I've got about a 17% chance of running it in less than 70 minutes. I hope this helps, and have fun in your stats class.